From the given double integral, we first identify the region of the integral. So, from the double integral, we see that first we integrate with respect to y, and so therefore the limits are y equal to x squared minus 5 to y equals x minus 3. So, we have the equation y equals x squared minus 5. The graph of this equation is a parabola opening upward and shifted down by 5 units. So this one is the equation of y equal to x squared minus 5. And the upper limit of this integration is y equals x minus 3. This is basically a straight line with the positive slope 1 and y-intercept negative 3. So here I have drawn this straight line with the positive slope of 1 and also the y-intercept is negative 3. And so first we consider a vertical strip. That is, we find the area of this vertical strip which ranges from x squared minus 5, that is the lower limit of y, to the upper limit of y is x minus 3. And then we move this vertical strip starting from x equal to 0 to x equal to 2. So by the way, we cover this area of the region of the integral. So we can say that this portion is the area of the region of this double integral. We are now going to switch this order of this integration. That is, we are now going to consider horizontal strips instead of the vertical strip. So after switching, we still have the same region of integration, but we have to divide this region into two parts as I have shown in the red color. So this is the division where we have this line y equals negative 3 divides this region into two parts. So therefore, when we consider the area of this region using the double integral, we have two areas. This one is the first one, and another one is this one using the horizontal strip. So we can write down this in terms of double integral as let's put this first x varies from 0 to this curve, because this horizontal strip touches this curve y equal to x squared minus 5, which means we have to solve for x from that equation. So solving for x from this equation, we get under the root of y plus 5 equals x. So therefore, the lower limit of x here is 0, and the upper limit of x is y plus 5 under the root. And then we move this horizontal strip starting from y equals negative 5 to y equals negative 3. So we put negative 5 to negative 3, and then we put this f of xy, and this time it is dx and dy. This is the area of this first region. Let's say if this is a1 and the second one is a2, so we have to add this with the another region, and for that, let's say the area of this region is A2, and this is given by, we consider the horizontal strip. The lower limit of the horizontal strip is this line. So therefore, we consider x from this equation. So x equal to, we have y equals x minus 3. Solving for x, we get y equals, I'm sorry, x equals y plus 3. So therefore, this becomes the lower part of the limit y plus 3, and the upper part of the horizontal strip touches this parabolic. So once again, it's going to be under the root of y plus 5. So we write down y plus 5. This is the upper limit, and the lower limit of y is we uh, push this horizontal strip starting from y equals negative 3 to y equals negative 1, because this point, which is the point of intersection of the parabola and the line, solving these two curves, we get y equals negative 1. That is 2 comma negative 1 is the point of intersection. So therefore we move this horizontal strip from minus 3 to minus 1 to get the area, and we also put this region of integration f of xy, and it should be dx and dy. So we have to add these two areas to get the required area. So therefore, we say that this double integral the given double integral 0 to 2 and then x squared minus 5. The upper limit is x minus 3. F of xy, this is with respect to dy dx. This equals double integral of the first area is 0 to root of y plus 5, 0 to root of y plus 5, and for the another integral it is negative 5 to negative 3 f of xy. This time it is dx dy plus this one, which is y plus 3 to root of y plus 5. So we put the another double integral y plus 3 to y plus 5 under the root. And for the first integral, it is from negative 3 to negative 1. This is f of xy dx dy. And so we have written this given double integral as a sum of two double integrals after switching the order of this integration. And this means answer choice B is correct.